Good morning, everyone, and welcome to Greener's first UK webinar, an introduction to batteries. My name's Andy Parker, and I'll be your host. We're excited to have you join us as we explore battery technology in delivering a cleaner, more flexible, and cost-effective energy solution. Joining me today is John. John is Head of Commercial in the UK, and Robin is our battery systems specialist. More from them later. Before we dive in, let me give you a quick overview of what we'll be covering today and how the session will work. So over the next 30 minutes, we'll take you through the basics of battery technology and why it's key to achieving lower emissions and greater energy flexibility. We'll also be discussing our EMS, our energy management system, which ensures maximum efficiency and reliability. We'll also be going through a number of real-world examples of how businesses are using mobile batteries to cut cost and reduce their carbon footprint. Now, throughout the session, please feel free to ask questions using the chat function. One of our experts will be on hand answering them as we go, and we'll be saving some of the more interesting ones for a live Q&A towards the end of this session. Now, before we get into the details, let's take a moment to introduce Greener Power Solutions. Greener Power Solutions was founded in the Netherlands with a clear mission, and that was to accelerate the transition to a cleaner, more flexible energy future. And it all started with a simple but pressing challenge. How can we reduce the reliance on diesel generators in industries that need temporary power? And the answer lay in battery technology. And in 2018, Greener Power Solutions was born. Our founders saw an opportunity to make temporary power more sustainable, efficient, and cost-effective. What began as a small fleet of batteries serving the construction sector and event sector in the Netherlands has now grown into the leading provider of mobile battery solutions across Europe. And today, we operate a fleet of over 185 batteries, delivering clean energy to a wide range of industries, from construction to grid support, events, and EV charging. But our solution go beyond just hardware, and what sets us apart is our EMS, our energy management system. This was developed in-house to optimize energy usage in real time, making clean power not just possible, but also practical. As we all know, the UK is going under a major energy transition at present, and we have ambitious net zero targets and a growing demand for cleaner, more reliable power. But there are significant challenges. Grid congestion. Many businesses and projects struggle with limited access to the grid, which cause delays, which then ultimately increase costs. There's a significant reliance on diesel generators. Despite the push for sustainability, diesel remains the go-to solution for temporary power, which again, that produces high emissions and increased fuel costs. We've also got rising energy costs, and with the unpredictable challenge of energy prices increasing, businesses are seeking smarter and more efficient alternatives. And a big one is sustainability pressures. Now, companies face regulatory and social pressure to cut carbon emissions and adopt greener practices. Our battery technology is already making a difference across various sectors in the UK. On construction sites, we're helping major projects reduce their diesel consumption by up to 80%, slashing emissions whilst ensuring reliable power. Across the event industry, festivals and outdoor events now have access to clean, quiet energy without compromising reliability. And also grid support. By deploying our batteries for projects that are waiting for a grid connection or a larger grid connection, we allow projects to start today that would otherwise stall and be delayed. An EV charging infrastructure. Our mobile batteries are filling gaps in grid availability, accelerating the rollout of EV charging hubs. Now, as we're all aware, the path to net zero requires bold innovation. Battery technology is evolving rapidly, with allowing for greater storage capacity, longer lifespans, and smarter integrations with renewables such as solar or wind. At Greener Power Solutions, we're committed to driving this transformation and helping businesses across the UK meet their energy sustainability goals. And with our solutions, businesses can become easily emission free. I'll now hand you over to our battery specialist, Robin, who will provide you with a basic overview of our batteries and EMS system.
Thank you, Andy, for your introduction. I am Robin, one of the system specialists. I've been working at Greener for 5 years, so I'm going to tell you a little bit about the battery system, starting with hardware, going on to software, and then to the web applications. So we have our systems, which is basically a 10-foot shipping container in metrics, so not imperial units. That means about 2 meters 40 wide, 3 meters and a bit long. It's literally a standard shipping container. Weighs about 9 tons. I prefer to say 10, so it's significantly heavy. Within the system, within the machine, there's a couple of components. There's the actual battery system, which is 8 or 10 BMW i3 battery packs. So they took the car, and we only needed the battery. So they stripped away all of the car components, and we got left with only the battery pack itself. So you should be able to swap it with something which is on the road today.
Okay.
So we've got 8 or 10, giving you a 336 or 422 kilowatt hour neat or a brute storage capacity.
Yeah.
We can only store this energy in a DC capacity, so we need a inverter or converter, which is the second component in the line. This machine converts the energy from an AC grid to a DC bus to be able to store it or to charge or discharge our battery systems, which is basically a bucket, right? You can put the energy in and take the energy out.
Okay.
Which takes me to the next part. You could see a battery system as a really large storage device, or if you're talking about water to make it really visible, you can either fill the bucket really quickly with a lot of water very quickly and then shut off the pump.
Mhm.
Or if you have a very small supply and you once upon a time need a very large amount of water, you fill the bucket slowly, and then when it's full, you take the bucket and empty it again on wherever you need it. In order to do this, we need to charge and discharge the system. So what you see is that our entire system is parallel to the bus.
What's the bus, Robin?
The
People
bus
that might
is
not know.
the pass through or the connection within the main power line
Yep.
going the main power line within a system. In this case, within our battery system. We will talk about a external bus later in one of the cases, which then of course is as big as you need it.
Yeah.
In this case, we have an input which is rated at about 250 kilowatts, 400 amps. We have an inverter which is rated at about 250 kilowatts, 400 amps, which all feed into into the output. Because the input and the output are rated at 400 amps or 250 kilowatts, you can see that the input power lock system is single and the output is double.
Yeah.
So you can pass through the input directly to the output, and then you can stack on top of that the inverter power for as long as there is energy in the system. So that's a little bit about the hardware and basically how it works.
Okay.
So in order to make the hardware do what we want, it needs to be controlled. Well, there's a little hierarchy within the system. We have the OEM devices and we have our own EMS system, which then controls the hardware of the OEM or the original equipment manufacturer. So you've got all the parts, the inverters, the batteries talking to a PLC,
Yep.
PLC talking to a computer. Computer does all the very fast calculations and difficult algorithms, and then we tell the computer what it needs to do from our energy management system as we talk to all the other assets
Yep.
which are within the microgrid available. Right. Because we are, so I've already explained to you the hardware, a little about the EMS which runs locally. Obviously, it's really nice, as it is a very big computer, to make it available via the web. So we have a internet connection coming from the battery, which could be either a cell phone connection or a DHCP hardwired connection from the outside, depending on your project and where you are. So the greener eye reports all of the data that it gathers.
Mhm.
So that's input powers, output powers, inverter powers, and bits and bobs from the other machinery, and pushes that into a database in the World Wide Web. So that's what the watch does,
Yep.
which runs on our greener eye.
Yep.
And because we are greener, the greener eye is green. From there, we then read out the database in one of our own in-house developed
Platforms.
platform,
Yep.
which then has the dashboards
Yep.
in which we have our graphical interfaces. So you can see the historical data for your project.
And we also allow our clients,
Yeah,
basically
so
our
that's
partners, to see this platform.
absolutely.
Yep.
Otherwise, this is the thing that gives you lots of insights in what actually happens at your site.
Yep.
And then we'll talk about these. So if you then have all the data uploaded, you can then have an insight in these. So these are a few of the topics that will be made available and give you available to be seen
Information.
information.
Yep.
So that's the amount of energy stored at this point in time, or how the energy storage has been going up and down during a time scale, how much the actual peak power was on your project, and what the setup is at this point in time.
Mhm.
We can also, at a certain interval or on request, provide you with energy reports which are useful to prove that you are within the permit of your energy farm.
Yep.
So after having explained to you a little bit about the hardware, the software, and the platform and dashboards, I'm going to hand you over to John, who's going to tell you a little bit about the real-life cases.
Yep. Thank you, Ron, as always, for your technical knowledge and input. I must say I'm always amazed by my Dutch colleagues, how they have a far better grasp and use of the English language than I certainly do. What we're now going to do is we're going to run through three case studies, all with varying levels of complexity. I'm going to do the first two, and then I'm going to pass it back over to you, as it's a far more complicated setup than I can mostly deal with. So here's the case study one. It's a standard hybrid setup, but it's for an EV site. So what were the challenges here for our partner or our client? The EV chargers had been already installed, but there was no immediate grid access.
Mm-hmm.
So when obviously we were talking with our partners, they were discussing about the setup potentially was going to be 2 times 400 kVA generators, one supplying the load, another one there for resilience, and also if that one generator fell over. But as you can most probably imagine, a lot of the EV charging sites are in built-up residential areas. So when you start looking at your noise and pollution issues, this then could potentially stall these projects because there's going to be a lot of blocking with regards to the generator, 400 kVA generator, running 24/7 nearing a built-up area. So what Greener did in partnership with our partner is we bridged the gap. We were able to take away or displace enough fuel, but take away 2 400 kVA generators. We put one of our Greener batteries, which Robin went into some detail earlier, onto the site, and then we powered it with a 200 kVA generator. What this enabled us to do really was power those sites most of the time from the battery. So the battery was dealing with most of the load, and when our battery state of charge was reducing to a certain level, maybe 25% state of charge, it would call upon the generator to charge the battery back up. But that is obviously very important because then we could get through the night runnings. And I think we discussed earlier, I mean, one of our batteries, how many sort of charges do you reckon it could do in a night?
At least 3, taking into account that a modern EV car has between 50 and 100 kilowatt hours battery capacity of itself.
Yeah.
Mm-hmm.
So a 422 should do at least 3 car charges before needing to recharge. But in reality, it'll probably be more because you never go from 0 to 100% charge.
So in that process, then we were able to get the site live. The battery was dealing with the most of the load. So what were the results on this case study? Lower fuel consumption, reduced emissions and servicing, and in particular for this particular application, quiet nights in residential areas. But I'd also just like to say one other thing before we move on to the second case study. I think there's a lot of obviously there's a lot of delays, as you alluded to earlier, Andy, around grid delays.
Yeah.
I think what we need to start looking at is little grid connections. I think we discussed 50 amps potentially, Robin, right, as the lowest level we could go to, because there are these small grid connections out there in the UK and across Europe. So whilst you're waiting for a larger grid installation from the grid, why don't you look for these smaller grid installations? Because our battery, alongside a 50 amp grid connection, could quite have easily taken this completely fossil free with the grid trickle feeding our battery overnight.
Yeah.
So it's just something to think about when you're looking at sites. Please look for those small grid selections.
And even if you've already got stuff connected to it, you can meter existing
Correct.
grid connection, and then we can use the excess amount of usable power from that grid connection.
Okay.
And don't forget, if you have a 50 amp grid connection free phase, that's nearly a megawatt hour of energy
So
right
it's quite
there.
significant.
It's a lot of power.
That's a lot of energy.
In
A lot of
day.
energy.
But I think at the moment
Yeah.
we're not utilising it, and we're just going straight to a generator, and I think we could do more. So I'm sorry, and these are the notes that we've just discussed. I know you're all going to be getting this documentation post our webinar, so please feel free to read this at your own leisure and your own time. And then if there's any other questions post-webinar, please reach out to somebody within Greener or ourselves, and obviously we'll answer those questions. Case study 2, slightly a more complex setup. As you can see, you'll see 2 batteries there in parallel. But it's quite a common story for us that one of our clients or partners will come to us with something called a peak power profile. And what that means is they will come to us and suggest that all the power is going to be on at once, at one time. And I'm talking about the kettles being switched on. I'm talking about, lights being switched on and heaters and so forth and so forth. The likelihood of this happening, in our experience of nearly 7 or 8 years of experience, is that's very unlikely. But on this particular site, as you'll see, the peak power was over 1,000 kVA if that peak load had happened. Now, I would suggest a traditional setup for that, Robin, would most probably be 2 times 500 kVA generators on load demand, maybe more. I think you think maybe more than that. And one of those 500 kVA generators would be running 24/7. There's a lot of diesel running for 24/7. So what we did, again, working with one of our partners, you can see that we've got 2 Greener units there connected on the input to the common bus. And then you'll see 300 kVA generators also fixed to the common bus there, but on our fixed export. And what this setup is supposed to do, and what it does do very, very well, is our batteries in parallel will reduce the state of charge at the same time, but whilst we're providing power to the load. If the load and the batteries keeps depleting, if our batteries get to a certain state of charge, 35% in this instance, it will call on its fixed export for generator 1.
Okay.
And if generator 1 will then start and also provide power through the common bus to the load as well, but also look to power up our batteries there. If that isn't enough and the power on site is greater than what we have delivered here, it will automatically, at state of charge of 30%, call for generator 2. And it's the same system, so it calls for generator 2. Generator 2 is then also, with its excess power load, powering up our battery again. But if the load is too high again, obviously our batteries are still depleting. So our batteries will now deplete to 25%, and then that will call generator 3, which is there for resilience. It's going to be more than the load that's required on this site. And that job of that generator is to purely charge our batteries back from 25% state of charge to 40% state of charge. And at that point, that generator 3 will switch off. So what I'm saying here is, and hopefully quite clear, is this is where we are running these generators at the most optimum and efficient level possible. These generators, again, aren't idling, as most people would say, Robin, at night.
No.
If a 500 kVA generator with this load profile at night, it's sitting there and it's running at idle, all sorts of problems are going to start coming around if they're stage 5s in particular. So what it's doing is it's running these generators hot for the optimum time possible, and we're allowing our batteries to, with our power, to deal with most of the load. So again, what were the results on this case study? Again, it's a common story really. Lower fuel consumption, reduced emissions and servicing, which I think is really important on this setup. The servicing here would have been vast, I would have thought, with 2 500 kVAs.
Well, especially if you set it up in such a manner that generator 1 and 2 are in a rotating schematic.
Yes, very good point.
You go from 100% hour running during the week.
Yep.
Just by having the setup to 50, and then if you have 2 generators, you're doing 25%. So you could potentially go from weekly to monthly service intervals.
And I think that's really important. Those are sort of conversations that we are having with our partners and our clients, because I think we're all in this in together, and we're looking at ways at how we can, as you alluded to at the start, Andy. So, and quieter operations and cost savings. So I think those are the two case studies that I'm going to go over today. I'm now going to pass you over to my great friend Robin, and he is going to go over case study 3, which was a process that evolved over, I think, 12 to 18 months, and it's got some great news stories.
Right. So these are, of course, the notes from John's story.
Yep.
Please read into them if you get the
at your own leisure.
Presentation at your own leisure. Right. Case 3. So this is a little bit of a story. It has basically 5 steps. We got a question in, which is number 1. There's two 1250 kVA generators, stage 5 running. Well, so we've already generally touched upon. Stage 5 generator needs to have a significant load on there to be hot enough to actually make the stage 5 part work. So that's the urea reaction in a exhaust system.
Okay.
If that doesn't work, you get these very big crystals forming, and at some point you will have to replace the entire exhaust system, being costly and time consuming. So that means that in order to have that load on, they would have placed a 600 kilowatt load bank. And a load bank is nothing more than a very big radiator. You know, everybody has, or a lot of people have these. They call it a barbecue.
Yep.
So good parties in the summer, but a little wasteful if it's already 35 degrees outside and this is standing in the same field where it's 35 degrees, creating a hot summer breeze. It's already warm. So after we saw this, we thought, well, we can step 1 is to use the energy that you're creating to keep the generators healthy and stick those in the battery. So we very quickly came to step 2, which is a battery doing basically the night shift when the load drops off under the 50% load of a single 500 kVA generator, and during the day run the entire generator farm in low demand scheme. So this is already going down in diesel fuel consumption, going down from a little over 3,000 liters a day in setup 1 down to 1,394 or a little under 1,500 liters
So
a day.
Halved it by that one change.
Yeah, so that's 1,500 liters of diesel saved.
Yep.
Every 24 hours at, what is it, €1, €1.20 a diesel?
Say 120.
That's
it's a lot of money.
very easily. That's every day, right?
Yep.
Every working day. In the weekends when there's not been work, it's even more. So then after doing some more waiting for it, gathering the intelligence or the measurements, because we placed a measuring device over the entire generator farm. We know exactly what the load is doing during daytime hours, during working hours. We noticed that we could even reduce the average load on the generators up by from 50 to 75% by putting in 300 kVAs instead of 500 kVAs, meaning that you're getting even more kilowatt hours out of a generator set. This step again gave us a 50% reduction from 2 to 3. So going from 3,000 to 1,400 to 750 liters a day. Nothing changed to the load. We did not change anything. We didn't tell them, they didn't do anything different in their behavior on the load side. This is just dealing with the energy generation system or the energy farm. After we had done that, we saw that there were pretty high step loads with the generators we're having a little bit of trouble with. So we said, well, what we could do is we use the speed of the batteries primarily over the generator. So if we took 2 batteries in parallel, which both would be doing exactly the same thing, kind of the same as the case 2 that John just now mentioned, they will deal with all those hits simultaneously and equally. Putting the generator then in a fixed power mode, so it's only converting the diesel into energy, into kilowatt hours. we will be able to power the entire load from the batteries until the batteries are depleted, fire the generator,
Oh.
and then refill
Yeah.
the batteries as needed. That resulted in a 6.5 hour 75% load upon the generator at 50 liters an hour, giving us a grand total of 326 liters
Per
a
day.
day. So going from step one, which was about 3,000 liters a day, to
Nearly 300.
300, a little over 300 liters a day. It's a significant reduction, right? That's like 10% of the original.
Yeah.
Just about.
Yeah.
So
Yeah, I think so. But I think it's amazing in the way as also is the way our EMS, the way we can monitor the power, which I think is a really important part, obviously, of Greener as well. Obviously, the battery and the hardware, but it's also being able to take a site, like complex setup site like this on a major construction site, plug in one of our energy monitors and say, let us look at that for you. Let us monitor it. Let us put it through our systems.
Give an advice.
And see what we can do to create a better, more efficient and sustainable setup, but you still will have no drop off in your power requirements on your site. I think that's a really great story.
Yeah, and if they then ask us about costs,
Yeah.
so if we then look at the daytime savings, so this is every 24 hours, I think that at day 3, the other 5 days are free.
Yeah.
Yeah. Yeah.
Absolutely.
We again summarize this for your convenience and at your leisure when you're getting the slides.
Perfect.
Over to Andy.
you.
Thank you.
Thank you, Robin and John. I think that kind of gives you guys a bit of an insight, but it kind of brings us now to our Q&A session. We've had a number of questions from the chat, and I think that we can dive into a handful of now. I'll just pick a couple at random. I'll perhaps put them to you guys. Hopefully you'll be able to answer. We've got a question from Richard. He asked, how well do your batteries deal with an inrush currents for large motors? I think, Robin.
Well, so if we the inverter has a step-up load of 100% in one step, having 4 millisecond step-up.
Okay.
There's a little bit of pros and cons here, but in general, we will be able to handle this. This is one of the main reasons that case 3 really works.
Okay, perfect. Okay, hopefully, Richard, that kind of answers. But if you've got any further questions, then feel free to reach out to myself and the guys, and we'll kind of take that one offline. We've also got a question here from one of you guys. What challenges do Greener Power Solutions face when deploying batteries with no available grid power? And how do you come these challenges? I think we kind of touched on it a little bit, but in short, how would you kind of summarize?
People not fueling their generators will be a main one.
Okay.
Yeah.
Okay.
No, I think going back to, I read the question right or heard it right. I think it's we must start looking at small grid connections as well.
Yeah.
I think. And I think it's an education piece for everybody, really, and we're in part of that. Greener are very much part of that education piece as we go through the transition at the moment. But I think when you look at a site, when you look at whatever power demands you might need, I think rather than instantly thinking about a diesel generator because of that question highlights, think about what is out there, what is possible from another source of energy, and then obviously we want to be having those conversations and working that way.
Superb, thank you. We've got another question here. Does battery chemistry make a difference, and should it be considered when choosing a battery storage system? I think I'll give that to you, Robin.
Please do.
So in the end, the chemistry of a battery is only a medium. Buying batteries nowadays is like buying a computer in the 80s.
Okay.
The moment you've bought something, it's already out of date. Obviously, the battery systems that we now have been running for a little while, so the lithium-ion systems.
Okay.
If you will look in the market now and buy, and if you buy new systems now, they will all be LFP, which is the next generation.
And what is LFP?
That is lithium ferrous something. I am not a battery chemist. I know about the applications.
Okay.
But they are. Obviously, they're more. It's more capacity and more heat resistant.
But it's evolving, isn't it?
Absolutely.
I mean, it's like look at a car. Look at a car 20 years ago and look at a car now. I mean, I'm just saying technology will always be the creator of solving our problems.
Yeah.
And I think it's no different from batteries. Batteries are evolving all the time, and obviously at Greener we want to be at the forefront and making sure we have the latest, best technology to supply to our client base.
Excellent. Okay, and we'll perhaps take a couple more. We've got one from Ollie. He asked, how can you integrate solar installations to a microgrid using our batteries?
Right, so a solar system basically is a grid following device.
Mm-hmm.
So as the microgrid created by anything, or grid created by anything, the solar will just push their available energy upon the grid.
Okay.
And if there's a battery system there, it will just absorb it. Obviously, you could imagine that if there's a very, very sunny day and no load at all, there is the chance of having too much energy available.
Mm-hmm.
So when applying batteries, you always need some form of curtailment or a manner to switch off or decrease the power delivered by the solar.
Great stuff.
Or more batteries.
Well, that is an answer. Okay, and I think we'll just maybe got time for maybe two more. With a question coming in about the future. What investments are Greener making to ensure its fleet of batteries can meet demand from clients as more companies become aware of this alternative to diesel generators? John, perhaps?
Yeah, I think go back to what I alluded to earlier. I think Greener want to be at the forefront. I think the guys and the founders and the investors have made a conscious effort to make sure that we stay at the forefront and leading. So people above me are definitely in deep conversations about further investment into a battery fleet. I think we specialise in a certain size of battery. I think we see from these conversations and what we discuss a big opportunity to keep developing there. So I would suggest that Greener will continue to develop, buy and supply the batteries of a certain size. And as I said, be at the forefront in an ever-changing market. And I think what we've built with long-term relationships with some of our key partners across Europe has got our brand into a great place.
Yeah.
And I think now we must still keep developing and growing.
Yeah.
Have you got anything there, Rob?
And integrating multiple little grids to a large grid with the appropriate hardware
Yes.
is a thing that we are busy developing.
Yep.
Okay, and thanks, John. And we'll take another one, I think. We've been asked, what is our cyber security policy for remotely installed equipment communicating with our central hub? What is our cyber security policy?
I'm afraid that needs to be asked to the development people. We are compliant to the
Yeah, I think it's a question.
Might not be a question for us. No, not really for me.
All we can say is from a security perspective, and we are on multiple high alert sites across Europe and UK. So I would say that we've been checked by governing bodies.
Is it NIS 2, which is the at least EU kind of which we are compliant.
Yeah.
And in the end, the system is standalone. So if you disconnect the internet, once it's programmed, it'll run.
Okay, good. We're getting some great questions here, guys. If you want to keep firing away, we've got a few more minutes left. There's a lot of questions coming up that are quite similar. We've just got another one here. How do you determine if my application is right for the battery? Is asked by one of the guys and girls from the audience. How do you determine if the application is right for the battery?
I think I'll let Robin go from a technical perspective, but I think we obviously got our in-house Greener calculator that we monitor and we look at and that we've built. I think looking at the load profiles we discuss when it comes through from a client.
Would that be the monitoring?
Yeah, I think I think we've also got to be very clear here that the battery needs transient loads, right? So we don't, we as Greener employees can look at a profile that comes through and can suggest that the battery is just not going to be able to deal with that constant load.
Yeah.
So initial conversations with that client to understand what that site's powering, we can have a pretty much good estimate, from a welfare unit, from a tower crane, from multiple sites that we've developed and worked with. I mean, we would have a decent idea, wouldn't we, if we thought the battery would be a worthwhile exercise.
The less stable the load is, the better a battery would work. So if you have if you're only supplying heaters, well, size your generator correctly is a thing.
Okay.
Yep.
Okay. Thanks, guys. That brings us to the end of our Q&A session, and to the end of our first UK webinar. I hope you guys found it insightful and has given you a clearer understanding of how our batteries can address the energy challenges that your businesses face. And before we sign off, I'd like to invite you to our next webinar, which is on the 5th of June. And we'll be doing a deep dive into hybrid solutions and how generators and batteries work together. We hope to see you there. However, in the meantime, feel free to connect with us on LinkedIn or visit our website for more insights. Thanks again for joining us, and have a great day.
Thank you.
Thank you.
Ciao.
Ciao.